from JPEG AI reference materials. The photograph was taken by DSLR camera and also mirrorless and smartphone, different smartphone, and in RAW format, all of them with all EXIF data, and the collected data from online sources also mostly in RAW format with all EXIF data, or in some cases that it was JPEG data, then it should be the quality 98 or higher, and with all EXIF data should be included. Then the capture date also should be 2020 or later. So we had this nearly 3,000 candidate, and we extracted the D feature, and then we cluster them in 60 cluster using k-mean clustering, and then from this 30 cluster, we select one source image per cluster that maximize the content diversity, and for the rest of the 30 cluster, we did analysis with to maximize the metric disagreement that I will discuss later, and then we selected that 30 other, and 10 more, the 10 remaining cluster were source image were selected from different material to increase the coverage for screenshot, illustration, AI generated content, product, and so on. So the final 70 high quality, so we have final set of 70 high quality source image. And here this you can see the semantic clustering that was conducted on this 3,000 nearly 3,000 candidate image, and with the k-mean it was used to cluster, and 30 image was used per cluster. However, we didn't select the center of a cluster for each cluster, because often, for example, if you have image of included the sky so far, likely the center of the cluster, it will be the content that is shared with all this other image in the same cluster. Is often it will be only sky, or for example, if the grasses is the main content of this cluster, it will be image that have only grass. So we also chose randomly one of the image to avoid choosing the central ones. So for metric analysis, we use these metrics: PSNR by SSIM, SSIM, VMAP neg, and Butter Ugly, PNorm, and CVBDP, and SSIM Ultra 2. So we collected the score we calculated for all the 20 distortion level per each source codec. 20 distortion level was selected, and we did this metric, and then using and then we calculate the PLCC, SROCC, and KRCC, and then the metric that it has this based on this equation reduce the it has the maximum diversity. So the this metric have the maximum disagreement about that image quality. It was chosen for as a sample of that cluster, but that was done only for 30 cluster. The other 30 cluster were selected the center randomly. So this is allow us to have a more challenging data set for the image quality metrics. So this is the selected 70 sources. You can see it is include different content from portrait, animal, landscape, crowd, low light scene, and product, and so on. Also AI generated and screenshots. So the image, then the data set we had in three category. So the original image, often it's 4K or very high resolution. So we need later to do subjective study with this data set as well, right? So for the subjective study, we selected some sources that we have exactly the source. It was chosen to be equal to the image it will be used in the subjective study. And some sources, we downscale the image to 840 by 944, that this resolution will be used in the subjective study. And in some other sources, we kept the 4K or whatever resolution, the original resolution, and we had the crop of this size for the subjective study. This is what discussion in JPEG I see about this, because there is a discussion that for objective evaluation, we should use the original, for example, 4K image for objective study, for objective evaluation, or we use the crop that it used in the subjective study only. So to have both category, we divide the data set to have these three different category of the image. So in here you can see the data set is have very diverse type of camera it was taken, and all the data has metadata, rich EXIF metadata, all the source images. So for image coding, each source image was encoded with 5 base codec. That this codec was encoded all the 70 source image, JPEG, JPEG 2000, JPEG XL, and ABIF. And the one learning based codec with JPEG AI, HOP is the high operating point. We have another JPEG AIC for base operating point that was used only for some of the codecs. And then 12 codec was used only for subset of the image. So only 2 source image per that codec. So in total, each source codec would have encoded with 7 codecs. John will discuss the image coding for the traditional, for the conventional codec. John, please.
Yeah, so for the conventional codecs, we basically just used a pool of candidate images that was created by varying the quality setting of the various encoders. Of course, quality or quantizer setting can have a different meaning. So we used a pretty large range of, when it's a quality setting that goes from on a scale of 0 to 100, we used the range from 15 to 98 in all the steps that are available. For those that take an integer value, for those that take a floating point value, we only use the integers to keep it a bit feasible. So this was done for all of the conventional image codecs. For HEVC and VVC, we used the quantizer setting that is available. There was one strange codec, which is not really a codec, which is a quantized PNG. So this is just reducing the number of colors and then using dithering to try to have a reasonable image. So we used the PNG quant tool for this, with the setting being the number of colors, going from 4, which is not enough typically, to 256, which is the maximum you can do with a palette PNG file. So these are the recipes, pretty straightforward. We just varied the quality setting and mostly used just default settings. So for JPEG, we use libjpeg turbo. For JPEG 2000, well, actually, this command line for JPEG needs to be updated. Sorry, I will update the slide. It's ImageMagick convert that we use with libjpeg turbo, which behaves slightly different than the default CJPEG tool, in the sense that it uses different quantization table, supposedly a better one. In JPEG 2000, we use Kakadu with the Q factor setting, which is perceptually optimizing. JPEG XL, just the default Q setting, and for AVIF also just the default. Next slide. Okay, we're already at JPEG AI, I think.
For JPEG AI, for JPEG AI, we followed the developer recommendation. So we encoded the image in Bitrate matching, it was disabled based on suggestion by the developer of the codec. The model index and the beta displacement was explicitly controlled. So we gave the beta ourselves and which model to encode with. And the same beta displacement was used for both Loma and Chroma channels. The code is exactly the command is here. And the target tools index with 0, 1, 2, 3, and the beta was swapped from exactly from the minimum possible value to the maximum with the step size of 50. So we created 148 compressed image per each source image for JPEG HOP. The same was used for BOP as well. So for this, you can see in here in this image on the left, for different model or tool index, you can see that they are operate on different bit rate actually. And so you can see that the model 0 provide create the lowest quality, and when model 3 the highest quality image. And for example, for model 3, as you can see, actually most it's likely the gain of the perceptual gain is not too much, and mostly they have the same quality. So to this, in here on the right side, you can see the sampled one. So we try to look to the image from 0 to 4 GND. This was because the JPEG AI C4, it headed for high quality to perceptually lossless compression, and that it would be approximately between 0 to 4 GND. And we estimated the GND using CVBDP and then mapped to GND using JPEG AI C3 dataset. So we fitted the model there and to find the mapping function from the CVBDP score to the GND score. So then we dropped the highest quality image because it has a lot of increased the bit rate a lot, 2-3 times, but there is no gain on the quality. So we dropped that sample, and then we chose 20 sample that in the with the plate that in the lower part of the curve, that it has no not dominated sample that with different model. Mostly they are selected from model 1, 2, and 3, and mostly 1, 2. So for Kolchak coding, Kolchak is different codec that is overfitted codec. So for each image and for each beta value, you train the image encoder and the decoder itself. So you have image encoder and decoder for each source image and for each beta value. So this is called overfitted model. And try to optimize this function that find this lambda we give it for that, and this the distortion and the rate. So there is this model that has Kolchak MSE. It was the original model, the first published model that used the mean square error for the optimization. And then a model in 2025 was proposed that used Wasserstein and some other perceptive optimization for the Kolchak. So we created 40 sample image, but changing the log space lambda value from 10 to power of -6 to 10 power of -2. So then this create 41 sample for each of these two images. As you can see, this is what's interesting between these two models, that the one that's perceptive, the Wasserstein, it has generated specific distortion that is not common in the traditional codec. For example, displacement of the this special displacement in the pixel values. For example, if you can see, I try in here changing between two slides just to look to the image. At the end of this, the text is Tour France. On the right side, you can see that it's jumping, but the special location of the some of this distortion is jumping from right to left. You can see it. It is hard to see probably in the screen that you have here, but there is physical displacement of this, in the special displacement of the pixel of the object here. And in here you can see that based on CVVDP mapped to the GND, that this the function, that rate torsion function, is not monotonic anymore for this perceptual Kulchik-Wasserstein, and it is, but because probably some of this distortion that in here, this displacement and some of this distortion might reduce the cost for encoding, and it will not be penalized by this Wasserstein optimization. And so this is good result might be in no reference situation. You would be able to still rate this image is much higher than with this same bit rate than other method. But when you have the reference there, so for full reference evaluation, you don't have this monotonic rate distortion function anymore, because they have this different characteristic. We kept both Kulchik MSE and Kulchik Wasserstein. And so codec assignment, John, if you continue, thank you.
Yeah, so there's, as Mohsen already said, for 5 of the codecs, we considered the base codecs that we used for all of the 70 sources. And then the next 12 codecs are only used for some of the sources, so that we have for each source exactly 7 codecs, but not always the same 7. So we did the assignment in such a way that we have at least 2 images for every pair of extended codecs, where we have both of those. It was a bit of a puzzle to do this assignment, but in any case, that's what we have. So 490 source codec combinations. So then we needed to come up with the selection of the distortion levels. So we want to have 20 levels in the range from 0 to 4 JND, or 21 levels if you count 0, but that's just the source image itself. So basically from 0.2 to 4 JND in steps of 0.2 JND was the aim. We do the estimation using CVVDP, so estimating based on CVVDP mapped to JND units according to previous data. So here you see a histogram of all of the images and their CVVDP value, and you see the peaks correspond to each of the targets, 0.2, 0.4, 0.6, and so on, JNDs. But of course, some of the images are not quite exactly on the target for various reasons, and I will go into those now. Okay, so some codecs cannot quite get to 0.2 JNDs. For example, WebP has a forced 420 chroma subsampling, which on some images just doesn't allow you to get to 0.2 JNDs. And also JPEG AI, we saw in some images that it just saturates at some point and cannot get below a certain ceiling of quality. So that's one thing. Here you see a histogram of color coded by codec, where of course the base codecs will have more samples. What the actual CVVDP value was for the first distortion levels, 0.2 JNDs. So you see many are close to the target, but there are some that are further away from the target. So one other explanation besides some codecs not being able to get that low is that sometimes the encoder settings are too coarse-grained. For instance, with HEVC and VVC, we only have an integer that has a limited number of values, and sometimes there's just not 20 different values that are inside of the range. So in this case, we have to add some images that are outside the range, and we added them at both ends, both lower and higher quality than the range. So this explains why we have some that are a bit lower. Other reasons are, well, again, the coarse-grained settings can also mean that we just don't have any image that is close to the target, even in the middle. The target is 2.4 and we only have an image at 2.3 or 2.5, then we have to accept some deviations. And also sometimes the minimum we used in our pool of images, so for the conventional codecs, that was a Q setting of 15, sometimes is too high quality according to CVVDP, which is probably CVVDP being incorrect, but we will only know that when we have subjective data. But it did happen on some images that according to CVVDP, the lowest quality setting we had in the pool was only 3 JNDs or something like that. So this is also causing some deviations. But all in all, if you go to the next slide, we have a good match. So of course, I'm not going to show all of the plots because there's a lot of plots you could make. So this is for source 10. This is the same image that Mosne showed before with Cool Chick having some strange artifacts. So we looked at CVVDP in JND units, the plot on the left, but it's the same information as the CVVDP on the usual scale. It's just remapped to JND units. Next slide. So you can see the different metrics do disagree. So these are this is for the same image, the plot for VMAF and for PSNRY. So if you would look at these plots, for instance, you would see that according to PSNRY, HEVC and AVIF are the best performing codecs on this image, whereas according to VMAV, it would be JPEG AI, and so on. So there is a disagreement. This is expected, of course.
Yeah, because we selected 30%, half of the image almost, that they maximize this disagreement.
Exactly. But even on the images that weren't selected because of this, there is also disagreement. So if you look at the histograms, the histogram for CVDP has these peaks at the targets that we used for selection. If you look at the other metrics, you won't see those peaks. The histogram looks smoother. So on the left, bottom left here is the VMAF histogram. On the bottom right is the one for PSNRY. So you see that the lines here are indicating the median metric score per distortion level, and these medians are still nicely monotonic in the metric, but the spread of metric values per bucket of distortion level images is more significant if you look at the other images. But in general, of course, there's still a lot of correlation as expected. You can also try to make an aggregated plot. So this is for all 70 sources. You do the following thing for each codec. You look at the range in the metric that is covered by all of the sources. So of course, for some sources, if you look at the complete set, there will be some sources where the codec doesn't go low enough or doesn't go high enough because of the reasons I discussed. So we don't always have the full range from 0 to 4. And if you select all of them, it's a very strict criterion to have all selected sources. So this is the plot you would get if you do this and plot the average BPP for a given metric score. JPEG AI, according to CVVDP, is performing the best of the base codecs. This is not a surprise, but it is not necessarily reaching the highest fidelity.
Yeah. We know from the previous study in JPEG IC3 that CVDP in JPEG in learning-based codec in JPEG AI performing lower than the other conventional codec, which is expected because it was not tuned in this new distortion type.
Mm-hmm. So if you look at different subsets of images, you will see some different behavior. So for instance, on the left is a selection of 19 source images that are kind of nature image with trees and grass and animals or whatever. And the one on the plot on the left are the 4 synthetic images, screenshots and illustrations and this kind of thing, not taken with a camera. So you see there is a dependency on the content, what kind of BPP you need for a certain quality, and also which codecs are performing better or worse. If you go to the next slide, you'll also see that there is also on the aggregate plots a lot of disagreement between the metrics. So for instance, if we look again at these 19 images of nature, just to have some subset, if you would believe PSNR HVS, for instance, then it would have most of the metrics agree that JPEG AI is performing best, but other than JPEG AI, according to PSNR HVS, JPEG 2000 would be the next best, followed by AVIF, and then a big gap, and then JPEG XL and JPEG 1. While according to Simulacra 2, the order of the codecs is completely different. So this is expected, but it's still interesting. If you go to the next slide, you can see that the disagreement can be very large. So if you, for instance, would believe VMAF, then the conclusion would be that where you need 1 BPP for JPEG 2000, you need 60% more to get the same quality in JPEG XL, while according to another metric, MDCT PSNR, you would get exactly the opposite conclusion. So 1 JPEG XL at 1.6 BPP to get the same quality in JPEG 2000, you would need 2.2 BPP, so a lot more. So basically, one metric says this codec is 60% smaller than the other, and the other metric says the opposite. So the gap is quite large, and of course, the question is which metric is correct, or is there a metric that is correct? So I think that's what this is about. Yeah.
Thank you, John. So following this question, which of this metric actually they work best, we in future work, so this will not include it in the current paper. But following the JPEG IC subjective test methodology that Dietmar just explained today again, that we will select from this 20 distortion DMA, 7 distortion level for the PTC and 7 distortion level for BTC. This distortion level, they have 4 distortion level common, but for BTC, they have more fine-grained distortion level will be selected than for BTC. We plan to conduct a large-scale crowdsourcing study to collect subjective triplet responses for both BTC and BTC, and then using that collected responses, we will reconstruct the psychophysical function or the rate distortion function for each source codec, and then we would have 490 rate distortion function and for 70 source image at average 7 codec per source. Then we will again doing the evaluation performance of the existing image quality metric, and as well as the call for proposal for AIC4, the metric that's submitted will be evaluated, and also we facilitate the development of the metrics to have a metric that would work best for the fine-grained image quality assessment. Also, we can analyze the codec dependence, perceptual artifact based on that, based on the metric that we did so far, and also based on the subjective data, and also this would, if we, it will support the codec evaluation and also improving the metric for fine-grained image quality assessment. So the data set, including the persisting source image, the compressed image, the reconstructed image, and the bit stream. Also, all the metadata, including the camera information, resolution, license, and source format, and so on. So the license, it will be CC by 4 share alike. So allow any research use the data for research. And also all the script for image classes, clustering, the metric disagreement analysis, and final source selection. It will be publicly available, as well as the metric that the source code used for this plot and so on. And the encoding recipe for all the codec and codec configuration, it will be also included. And this script for distortion level selection and objective metric evaluation, as well as the objective metric score that they calculated so far. It will be available publicly for reproducibility and also to support research in this area. Thank you very much.
Thank you very much for a great presentation. Are there any questions online or in the room?
Please, because in the room, questions? Yeah, because the
Can
paper
you
has
pass
not
the
been...
microphones?
Yeah. I really appreciate any comment to improve this work. So
yeah. Hi, this is Yanni. Thanks, John and Mohsen. I see the term VMAF and VMAF-neg being intermixed. Which one was used, VMAF or VMAF-neg?
It was VMAF-neg. For now, we only use VMAF-neg, so even this axis should be
okay.
changed. Yeah, we can, of course, once we have the ground truth data, we can compute all kinds of metrics to see how well they correlate. But for the purpose of the metric disagreement analysis that was done to select images, it was VMAF-neg.
Yeah, thank you. This is, in my opinion, the right decision. But the other question I have is, you mentioned you have images from fairly low, like almost 16 times difference in pixels. Are you running these metrics at the, I'll use the word native resolution of each image, or you are like rendering them at a certain standard size before you calculate metrics?
It is the metric. It was in here. We have this the resolution of the metrics here. So the metric. This is the source image that was selected right now, and the original encoded image. So the encoded image, the source image, they have resolution of 840, 944 for these two category, and for the last category, they have the original resolution. So this is the metric is in these three resolution. So in two of them is 840 by 944, and one category that includes 32 image, source image, and all encoding, they have the original resolution. That might be 4K or 2K or what.
So in any case, for computing the metric, we use the native resolution of what was used for compression, always. The results that I've shown here are for the full resolution images. So which is for about half of the images, it's the same as the resolution that will be used for testing. For other images, the image resolution is higher. So for 32 images, the compressed images are higher resolution, and they will be cropped for the subjective experiment. In that case, we will compute the metric both for the full image and for the crop. But in both cases, the metric will be running on native resolution compared to the compression. But of course, the metric results will be different for the crop than for the full image. And in my opinion, the correlation with the subjective results will be most relevant when we compare the same image. So the image that was cropped, the image that the observers saw. But we will also compute the metric for the full resolution image, and this will give us some information on how representative the crop is for the full image in a way.
I mean, there is disagreement there because some people like Joe from JPEG AI is supporting using the original resolution. So it is not really decided later how to proceed, but we will compute the score for both the crop and the original and see how they correlate with the subjective data and make decision later for the objective study. It's not 100% decided right now.
Yeah. But in any case, we're never downscaling the source and the compressed image and computing metrics on downscaled images or something like that. It's always just the native resolution of the images.
Yeah. My suggestion is to first of all calculate metrics for the purpose of correlating with subjective opinion only on the part of the image that the people see. There may be very small difference, there may be medium difference or large difference, but to eliminate the possibility that you have some localization of distortions that cannot be seen in one, my proposal is to always calculate the metric in the part of the image that is viewed by the subjects. Suggestion number one. Suggestion number two, regardless what is it that the people see, because there is a rendering phase that say, I forget now what resolution you flashed before, but let's say 600 by 1000, right? If that is the part that is shown to the users, you need to calculate 840 by 944. Let's suppose that this is what you saw. But based on the viewing conditions and HVS, you should be either up or down scaling, again, depending, right? If the user is really close to that patch, you may need to upscale or downscale if they're fitting. So essentially take into account HVS before you calculate the metric. But then again, you may want to do with and without the rendering compensation, as you like to call it, or viewport compensation is how we call it. So that may make a significant difference based on a similar experiment that I ran in the past.
Yes. So to clarify, in the this is not really the scope of this presentation, but in the subjective testing that we are planning to do, the test interface is such that there's no browser upscaling or downscaling going on. So the image is shown at native resolution. So of course, this means that if they have a display at a higher resolution, then the area of the image will be relatively smaller than if they have a low resolution image. And it's not a controlled experiment that we're planning to do. It's a crowdsourced one, so we don't control the viewing distance and the viewing conditions. So there is some aggregation going on implicitly in the viewing conditions there. But we did want to avoid having the big difference that you would get if you would just display the images at viewport size, which would be a lot more differences between different test subjects if they use different displays. So the images are in the test interface always one-to-one.
Yeah, so there is the responses that will be collected, not the same user answer all the questions, so only subset of the triplet each user answer. And then the psychophysical function will be reconstructed from all the triplet from all the users. So this different viewing condition, if there is any, I mean, you expected in some deviation in the crowdsourcing, it will be also somehow aggregated there. So you cannot really rely the psychophysical function to specific viewing condition. It is already somehow included all the responses collected from all user, from all this variation of the devices that might have. But we have some control thing on the browser, so the browser has to be maximized, as John said, and also the physical stimuli has to be PC or laptop. The physical dimension of the screen has to be at least 13 inch and so on. It will be enforced by the web interface. But rather, and also we have recommendation for the user to in what viewing condition should look to the image to do it, but we cannot really control in exactly what the user will follow and so on. We can control that if he change the browser zoom or something, we block it. This is possible to do it, but in physical, how he will really watching the image and so on, it is hard to control in the crowdsourcing.
Thank you. Again, we can take it offline. Thank you for the presentation. I think it's very valuable. Just log as much data as you can while you're doing the experiment, because you may be able to infer lots of information after the fact about users. Suggestion number one. And suggestion number two, when you're calculating, I'll pick one metric, SSIM, calculate multiple SSIMs, which would be the result of the source and the distorted being up or down sampled, and calculate, say, the SSIM rescaled at that. And then by data analysis, you're going to be able to infer which one of them fits best within the same family to your subjective data. That would be an indirect way of guessing on aggregate, as you said, because it's not going to be per user. What is the effective average viewing distance, and therefore use the most appropriate factor that should correspond to for all metrics. So it should be a global parameter estimation that I think is very easily done. But again, I think we're approaching the end of the session. Thank you very much, and looking forward to the subsequent results.
Thank you. So the paper for this, only for the data set, it will be publicly available soon, but the crowdsourcing study, it will be follow after that. Okay.
I believe that we have like 15 minutes to the end of the session, and Dietmar, you still have a question, I guess, yeah? No, okay. Yeah, there is another talk, but I don't see the people online.
How I can stop this anyway?
Okay. Yeah. So it seems that we don't have the other talk because, like, yeah.
So I would be happy to receive more comment because the paper we are preparing has not been submitted. So any comment for the data set itself, we really appreciate it. We can update the.
Send an email to the presenters. Obviously, now it's too late to invite them to present, and see if they can make an exception and tell us what time Thursday they're available, indicating to them that unfortunately we don't have the Friday slot, or invite them to present at the next SAM meeting.
Yeah. Okay.
Apologizing for not taking into account their, not being able to accommodate their preference.
Mm-hmm. Okay.
Is there anything else for today?
No. So we could continue discussion or...
Yeah. So, or everybody gets 14 minutes.
Or everyone gets extra 10 minutes, which is limiting chances for questions. Let's say I've got a question just could you clarify the clustering itself, how it worked?
Yeah, I can, may I share again the data again to open it? Share the screen, sharing, Windows, yeah. Okay, the sharing. So the clustering here. We extracted the feature, the feature for for the latent scale for this semantic model, And then we have the feature, and then we cluster them using k-mean clustering so that it will, and this what you are seeing here is UMAP of the visualization of that features embedding.
It's super clear for me now. Thank you. Sorry, I missed it.
Yeah. And the disagreement then, so in half of them, 30 clusters.
Also notice only 60 of the images were selected based on this clustering. There's 10 images of the 70 that were just manually added later on by trying to fill some gaps, like things like screenshots and so on that wasn't in the original selection. So that was added explicitly to cover all kinds of content.
Because we were aware that some of the codec, they have different behavior in such image, like AI generated image or the image that's screenshot and so on.
Yeah, super clear. Thank you very much. Are there any questions online or offline?
So this data set, probably we will also, I mean, we have to discuss it with Dietmar and John. Probably we will be happy to have the DOI for this data set as well from the VicWik.
Perfect, thank you. Okay, I don't see any other questions, but definitely if someone pop-ups with something, they can contact you. I guess you would be very happy.
Thank you very much again for your comment and also for listening. Thank you.
Thank you very much. Super interesting work, and yeah, I'm looking forward to see.
Enjoy your dinner.
Sorry, I've got another comment. Just a comment. Jack Hybrid, they considered the problem of you have objective metrics, and then you want to select interesting cases for subjective test. So I don't know, Enrico. Well, maybe you can just contact Enrico to point you to the work. Yeah. So they did hold the methodology how to come from the fact that you have objective metrics. And for many cases calculated, and you want to make a subjective experiment that is just a subset, but the subset that will resolve the most of the information, like you know, the most interesting cases, like the one that you showed, yeah, that one metric showed that this should be decrease in quality, another it's increase in quality. So this is a perfect case, yeah, to test. So this is pretty obvious, but they've got whole methodology for that.
Yeah, indeed. Actually, I mean, we worked quite a lot on the agreement and disagreement of metrics, and exactly for this purpose. I mean, one of the things I got from the presentation, if I got it right, is that if there is some disagreement, it's better to test this kind of conditions. I mean, disagreement between different objective metrics. That was the point of our work, and indeed that I think it's valuable from this point of view to reduce the size of a subjective experiment. Yes.
Thank you. I mean, the disagreement analysis we did for selecting the sources. So we have half of the sources almost randomly selected from the cluster. Half of the sources are the one that is most challenging for different image quality metric. We expected disagreement of the metric on the encoded source codec for that source codec. So that is the reason, not the subjective data to follow separately from this analysis.
It's an orthogonal question, and it's indeed a good suggestion to try to make subjective experiments more cost effective by reducing the set of pairs that is tested. This is currently not what we are planning for the subjective test. We're currently planning to do relatively complete design of the experiment, where basically we're not trying to use objective metrics to reduce the number of questions, just to be sure, basically. But I think in the future, for future experiments, it would be interesting. And once we have the base data obtained in the complete way, it will also be interesting to run simulations, I think, of subsamples of that data that are selected based on this kind of a priori information value as predicted by objective metric disagreement.
So I will be happy if you send me the paper that you wrote. Thank you.
Sure. I'll connect with Loic and we'll send some. Yes.
I mean, for subjective data, there is many also adaptive sampling that they look to the responses, the collected so far responses, and decide about the other one. This also might be cost effective, but there is a trade-off between them, what you are estimating. If you are estimating only the GND value, one GND, that might be they are more useful. If you need to estimate the whole psychophysical function, it's different story. So that is, we had a lot of discussion about this kind of thing when the methodology for JPEG AIC3 was suggested. What you are suggesting is relevant to the methodology itself for the subjective study, not, yeah.
Okay.
Thank you very much.
Yeah, okay, thank you very much. So I would like to close the SUM session. Thank you very much for everyone. And I give the phone to...
Thank you again to everybody, remote and in the room, for all the presentations and the good discussions today. Let's relax, go to our social event tonight, and we resume tomorrow. Thank you.
Thank you. Bye.